Ever wondered how an apple falls from a tree or how a car accelerates? These questions lead us to the fascinating world of physics mechanics. In the realm of physics, mechanics holds a special place. It's like the backbone, the foundation upon which the colossal edifice of physics stands. It deals with the motion of objects, from tiny atomic particles to the grand celestial bodies. But it's more than just observing motion. It's about peeling back the layers to understand the forces behind the motion, the invisible push and pull that directs the dance of the universe. It's about untangling the complex web of cause and effect. A ball doesn't just roll down a hill. It's propelled by a force, gravity, and that force in turn is influenced by the mass of the ball and the slope of the hill. So let's dive deep into the realms of physics mechanics and understand its two main branches, kinematics and dynamics. Imagine you're watching a ballet. The dancers move, but what's important is how they move. This is what kinematics is all about. In the grand theatre of physics, kinematics takes the stage as the study of motion. Yet, it doesn't concern itself with the forces that cause that motion. It's like seeing dancers glide across the stage, not caring about the muscle strength or the training that got them there. What matters is the performance, the motion itself. Now, every ballet has its elements, and so does kinematics. Let's look at the first one, displacement. Displacement is a bit like a dancer's leap from one side of the stage to the other. It's not just about the distance, but the direction as well. Just like the dancer, an object's displacement is its overall change in position. Next, we have velocity. Velocity is the speed of the dancer, but again, with a direction. Whether the dancer is twirling swiftly towards the left or elegantly stepping to the right, the speed and direction together make up the velocity. Lastly, we have acceleration. Remember the dancer who starts off slow, then suddenly bursts into a fast pirouette. That change in velocity over time is what we call acceleration. It's not just about speeding up though. Slowing down or changing direction are also forms of acceleration. The dance of kinematics is a complex one, full of leaps and twirls, starts and stops. Yet, it's through this dance that we begin to understand the world around us. From the ballet dancer's graceful pirouette, to the planets orbiting the sun, to the car speeding down the highway, kinematics is there, describing the motion in all its forms. So, kinematics is like the choreography of a dance. It describes how objects move, but not why they move. Now imagine trying to push a heavy object. The harder you push, the faster it moves. This concept of force and motion is the essence of dynamics. Let's delve into the fascinating world of dynamics, shall we? Dynamics, in its simplest form, is the branch of physics mechanics that investigates the forces that cause objects to move. It's not just about the motion itself, but rather about the why behind the motion. Why does an object move the way it does? What forces are at play? These are the questions dynamics seeks to answer. To understand dynamics, we must first familiarize ourselves with the laws of motion. These laws, first formulated by the great Sir Isaac Newton, form the foundation of dynamics. They are like the rules of the dance floor, guiding the movement of every dancing object. First, Newton's first law, also known as the law of inertia, states that an object will remain at rest or continue to move at a constant velocity unless acted upon by an external force. Think of it as a lazy dancer who needs a push to start moving or a nudge to change direction. Next, we have Newton's second law, which tells us that the force applied to an object is equal to the mass of the object multiplied by its acceleration. In simpler terms, a heavier dancer will need a stronger push to move at the same speed as a lighter one. Finally, Newton's third law, often phrased as for every action, there is an equal and opposite reaction. This means that any force exerted on a body will create a force of equal magnitude, but in the opposite direction on the object that exerted the first force. It's like a dance-off, where one dancer's move prompts an equal and opposite move from the other. By understanding these laws, we can decipher the forces that drive the dance of motion. Just as a dancer's strength determines their performance, the forces that act on an object determine its motion. So dynamics is like the strength of the dancer. It explains why objects move the way they do. It's like a perfectly choreographed dance. Kinematics and dynamics work together to create the symphony of motion we see around us. These two branches of physics mechanics, though distinct, are inseparable when it comes to understanding the world around us. Let's consider driving a car as an everyday example. Kinematics helps us understand the motion of the car, without concerning ourselves with the causes of this motion. It tells us how fast the car is going, in what direction it's moving, how it's accelerating or decelerating. But to fully understand why the car moves the way it does, we need to introduce dynamics. Dynamics considers the forces acting on the car, the engine's power, the friction between tires and road, the air resistance. It's the interplay of these forces that ultimately determines the car's motion. Or think about playing football. A player kicks the ball and it follows a certain trajectory. Kinematics helps us describe this trajectory, the ball's speed, its direction, its height at any given moment. But why does the ball follow this specific trajectory and not another one? That's where dynamics comes in. The force of the kick, the mass of the ball, the air resistance, the ball's spin, all these factors influence the ball's motion. In both these examples, you see how kinematics and dynamics are intertwined. The motion described by kinematics is caused by the forces studied in dynamics. And the forces studied in dynamics result in the motion described by kinematics. It's a two-way street. This interplay of kinematics and dynamics is not just theoretical. It helps us design safer cars, better sports equipment, more efficient machines. It helps us predict the motion of planets and galaxies. It's fundamental to our understanding of the universe. So, the interplay of kinematics and dynamics helps us understand the world around us in a more profound way. And it's a dance that continues, shaping our understanding of the physical world one step at a time. We've traveled through the intriguing world of physics mechanics, understanding the choreography of motion through kinematics and the force behind it through dynamics. Let's take a moment to reflect on the journey we've been on. We began by stepping into the captivating realm of physics mechanics, the branch of physics that deals with the motion of objects and the forces that cause this motion. It's the study of why things move or don't move, why they start or stop moving. It's the rulebook that governs the game of motion in our universe. We moved on to explore kinematics, the dance of motion itself. Here we looked at how objects move, their speed and velocity, their acceleration and deceleration. We saw that kinematics doesn't concern itself with why motion happens, but rather with describing motion in the most detailed way possible. It's like the meticulous choreographer detailing every move, every spin, every leap, but not worrying about what's driving the dancer. Then we delved into dynamics, the force behind the motion. This is where we started asking why. Why does an object speed up, slow down, or change direction? The answer, as Sir Isaac Newton told us centuries ago, is force. Dynamics is the study of the forces that cause objects to move or stop moving. It's like the passion that fuels the dancer, driving each step, each leap, each twirl. Next, we saw the interplay of kinematics and dynamics. These two branches of mechanics don't exist in isolation. They're like two sides of the same coin, intertwined and interconnected. The choreography of motion, kinematics, is driven by the force, dynamics, and in turn the force is influenced by the motion it creates. It's a beautiful, intricate dance where each step influences and is influenced by the other. Understanding these concepts, kinematics and dynamics, is vital not just for students of physics, but for anyone who's curious about the world around them. You see, the principles of mechanics are at work everywhere. Every time you throw a ball, drive a car, or even just walk down the street, you're living out the principles of kinematics and dynamics. So, in a way, we're all dancers in this grand choreography of motion. And with that, we conclude our journey through the fascinating world of physics mechanics. Remember, every motion you see around you is a dance of kinematics and dynamics.